Until the late 19th century, approximately one ship was mysteriously lost at sea each and every day. Back then, pirates, mythical krakens, or even Poseidon could be blamed for a ship's disappearance. With the development of shipping and the introduction of new technologies, that number has decreased. But even up to 2005, at least 2 ships per week continued to suffer sudden wrecks, taking many lives to the bottom of the ocean. Who or what is responsible for these crimes? It all comes down to killers, namely killer waves. To this day, scientists have no idea how to anticipate them, much less how to escape them. In this video, you'll get wind of how do waves play life or death chess with ships, why do 30-meter breakers exist contrary to mathematicians' calculations, and above all, what's the secret of the killer wave's perfect crimes? Killer waves were considered a myth for quite a while because their behavior is highly untypical. When ordinary waves get driven by the wind, we can observe a gradual increase in their speed and height. But things are different with killer waves. Their primary weapons are suddenness, elusiveness, and immensity. In the past, scientists were just entirely sure that a breaker over 21 meters high was simply impossible in the oceans of planet Earth. So, sailors' stories of ghost waves were considered a fairy tale. Modern theories also predict that the likelihood of such waves is negligible. They can appear once every 10,000 years at best. But sailors' experiences and satellite observations prove that such waves are not that uncommon. According to some reports, these rogue waves pop up once every 2 days. Scientific skepticism concerning the issue was only dispelled by the disaster involving the tanker SO Languedoc back in 1980. Back then, the researchers had the first and virtually only recorded appearance of such a wave. It was captured in a photo taken by the senior assistant to the tanker's captain of the SO Languedoc, Philippe Lejour. He took a picture of a 30.5-meter high wave that popped up out of nowhere. Its size was estimated after comparing the wave in the photo to the mast of the tanker itself, and the myth of killer waves became a reality. To get an idea of such a wave's impact force, imagine a 9-story wheeled building whooshing at you at 120 kilometers per hour. You won't even have time to post it on Instagram. Apart from the photos, scientists had no documented proof of the killer wave's existence. The investigation reached a deadlock again. The researchers managed to get a lead on the killer wave in 1995. The Draupner oil platform was between Scotland and Norway in the North Sea. Suddenly, amongst the 10-meter waves, one enormous wave hit, and the height of the wave crest was over 27 meters. There were measuring instruments for wave monitoring on the platform, and a laser wave recorder captured this indicator. That case jump-started the study of the phenomenon. The Draupner oil platform encountered the so-called solitary wave. Killer waves turned out to be a real criminal gang where each perp acts differently. Scientists distinguish several types of killer waves, and each of them poses a lethal threat. But which of them is the most dangerous? A water wall or solitary wave, which arises unexpectedly even in a relatively calm sea to strike and disappear just as rapidly. It crashes from above and can flood the upper deck, all devices, and break through a cargo hold. And that's what often proves fatal for most ships. That's the kind of killer the cruise ship Norwegian Dream encountered during its voyage. The wave hit the ship's bow, and if it just hit a bit more tangentially, the ship would have capsized. The only thing more dreadful than a wave like that is 3 of them. Three Sisters are three consecutive waves where the middle one is the highest. They hit a ship at regular intervals, easily capsizing it and enhancing the effect of each new impact. That's what happened to a massive Norwegian tanker called the Wilstar. As you can see, the damage was enormous. We're accustomed to thinking a wave is usually above sea level, but that's not always the case. The next killer wave is the best illustration of this. It's called a hole in the sea. First, two waves of average height arise, then a deep trench is formed between them. When a vessel's bow or stern gets into such a hole, the ship can get buried in the water column and instantly sink. And if the ship ends up on two adjacent crests simultaneously, it'll crack in two. But the title of the most unusual kind of killer waves typically belongs to square waves. These images of the Grand Voyager cruise liner drifting helplessly with the current and swinging from side to side were taken by rescue helicopters. Square waves intersect each other at roughly right angles, forming a chessboard-type pattern on the water's surface. The waves hold a vessel like a vice from all four sides. Thereby, a real sea trap is formed, and there's almost no chance of getting out of it. If death is the most common outcome in encounters with such waves, can we at least predict their occurrence? Humanity hasn't yet figured out how to withstand a 30-meter wave. The only way to escape such a spontaneous killer is to steer clear of it. But the technologies that could determine where and when such a wave would occur are still under development. In 2000, a European international project called MaxWave was launched to study killer waves. It used various techniques, including satellite-based ocean surface monitoring using the European Space Agency's ERS-1 and ERS-2 radar satellites. After an analysis of satellite imagery, scientists found that in just 3 weeks, more than 10 giant solitary waves were formed in the ocean, with heights exceeding 25 meters. Based on MaxWave, a new project called Wave Atlas was launched. The project's developers are engaged in creating a worldwide atlas of all recorded rogue wave events. Then they carry out statistical analyses on the frequency of their occurrence and determine where they are most commonly seen. For example, in the Agulhas Current off Bermuda, Cape Horn, the Grand Banks of Newfoundland, and the Greek coast. Wave Atlas will help find an optimal and safe route for ships. One hypothesis of the killer wave's occurrence is that adjacent waves merged to create one big wave. But the scientific community is still out of its depth in trying to completely unravel the secret of the killer waves. And that means the project's calculations can't guarantee 100% accuracy. Then how can we escape a killer wave? An ocean wave specialist and professor at the Max Born Institute, Gunther Steinmeier, believes that the most accurate tool for tracking killer waves was invented long ago. It's called a window in a drilling platform or a porthole in a ship. But the main thing is to take a look outside in time. However, even if you spot a killer wave coming, it'll sink your ship in one fell swoop before you know it. But that's not the only threat. There are other things that can suddenly hit you, and they're harder to escape. Like a sudden discovery that you're 30 years old and still living with your parents, or a song that brings a flush of memories of a messy breakup. What ruthless waves broke over you? Unburden your heart in the comments.